This flower trapped in Baltic amber is a stunner for its size and beauty. The flower, which is the largest known fossilized flower to be preserved in amber at 2.8 centimeters across, is nearly 3 times the size of other preserved flowers. The preserved flower, encased in amber from the Baltic forests of northern Europe, dates from almost 40 million years ago and is thought to be from an ancient flowering evergreen plant originally called Sadowski. Amber exquisitely preserves the delicate organs of fossil flowers for millions of years. However, flower inclusions can be rare and usually do not exceed more than 1 centimeter in size. The exceptionally large fossilized flower, which was originally described and named in 1872, is dated to the late Eocene, from between 38 million to 33.9 million years ago. Researchers believe that the rare size of Sadowski is likely from a large resin outpouring which would have encased the flower. The properties of the resin would have helped to prevent organisms growing on the flower and causing damage. This is the world's smallest dinosaur preserved in a 99-million-year-old amber. The amber, which contains a hummingbird-sized, lizard-like reptile, originally mistaken for a bird, was discovered in Kachin province of northern Myanmar. The fossil microdinosaur, named Oculentavis congre, is from the middle of the Cretaceous period, from a stage known as the Cenomanian. Its skull features large, bulging eyes, long, slender beak, and a jaw with numerous, sharp, insect-eating teeth. The huge eye socket, which contains a circle of tiny bony plates known as a sclerotic ring, is arranged within the orbit, forming a cone with an inner circle that indicates the creature would have had a very small pupil. This kind of eye is typical of many lizards of today that are active during the day and sleep at night, suggesting that Oculentavis had a similar diurnal schedule. Some of the skin of the palate and the tongue is also preserved, including the small pointed papillae on its surface. In modern passerine birds, such as the robin, these tongue bumps are directed backwards and prevent prey escaping from a mouth. There do not appear to be any feathers preserved, but some of the organic material has decayed to produce what is now a mess. Sadly, the rest of the animal's body is not preserved. This discovery is incredibly exciting for a number of reasons. Without a doubt, this is a dinosaur, but one that sits on the early part of the evolutionary tree that leads to modern birds. In fact, researchers suggest that it is quite close to the most famous of all bird dinosaurs, Archaeopteryx, which dates to the earlier late Jurassic period around 150 million years ago and has been called the first bird. Oculentavis is also incredibly small, with a skull just 15 millimeters long. It must rank as the smallest of any dinosaur. While it is not certainly adult, it is by no means a juvenile, meaning it probably wouldn't have grown much bigger. Researchers also point out that animals that evolve to become much smaller tend to come from isolated environments such as islands. For examples, there were once dwarf mammoths on islands like Crete, Sardinia, and Cyprus. Coincidentally, geologists have suggested that the Myanmar amber deposits were formed on an island that was part of a volcanic arc on the margins of the ancient Tethys Ocean. The discovery of Oculentavis is all the more fascinating because it was found in amber. Almost all fossils are formed from the hard remains of animals and plants: bones, teeth, shells, and wood. But the amber has preserved some of the soft tissues of the dinosaur, making it a very unlikely fossil. Amber starts off as a sticky liquid resin oozing from wounds on trees. But as volatile chemicals evaporate from its surface, the resin hardens into lumps that take some hammering to remove from the tree. This means it is even more unlikely that a dinosaur would get preserved in amber, as most dinosaurs are large, and the largest piece of amber ever discovered weighs a mere 15 kilograms. But not all dinosaurs were large, and one hapless Oculentavis congre, the smallest of them all, found itself in the wrong place at the wrong time in a forest in what is now Myanmar. It's not known if this little dinosaur had wings and flew into the resin, or if it became accidentally stuck, presumably by its feathers, while hopping through the branches of a resiniferous tree. The fossilized remains of Oculentavis will be rich in all sorts of chemical decay products that can often be traced back to original biomolecules. But unfortunately, it is doubtful that any DNA remains. DNA is such a delicate molecule that it rarely survives more than a few thousand years in humans, perhaps as much as 17,000 years in other animals, and just maybe around 1,000,000 years in fossilized bacteria. Oculentavis actually isn't the first dinosaur to be found in amber, however. In 2016, a piece of amber, also from Myanmar, was discovered with the tail of a feathered dinosaur about the size of a sparrow. When scientists were examining amber fossils, they discovered 100-million-year-old insects preserved with the damaged dinosaur feathers on which they lived. The bugs provide paleontologists' first glimpse of ancient lice-like parasites that once thrived on larger animals' feathers and possibly hair. The earliest bird louse previously known lived in Germany some 44 million years ago, and by that relatively late date the insect had become nearly modern in appearance. Consequently, early forms of lice and their evolutionary history have remained a mystery to scientists. While it stands to reason that feathered dinosaurs were plagued by lice-like insects just as their living bird descendants are, these newly discovered insects encased in amber are the first example to emerge in the fossil record. The bugs may not technically be lice, as their taxonomical relationship to the louse Ornithoraptora is unknown. But the insects in question, Mesophthirus unguli, appear as a primitive species very much resembling modern lice. The ancient bugs have different antennae and leg claws from modern louse, but their wingless bodies look similar, and they feature the large chewing mandibles that cause so much irritation to their hosts. Scientists found 10 of these tiny insect nymphs, each less than 0.2 millimeters long, distributed on a pair of feathers. Each feather was encased in amber some 100 million years ago in what is today the Kachin province of northern Myanmar. One feather showed signs of significant gnawing damage, suggesting that lice had established feather-feeding lifestyles in the mid-Cretaceous. However, later studies considered them as nymphal scale insect, probably belonging to Xylococcidae and not a parasitic insect that fed on feather. While this is a great addition to the growing record of parasites like ticks and mites that have been associated with Cretaceous feathers, the find also illustrates just how resilient such parasites are, since the same type of insects have lived at the expense of larger animals for at least 100 million years, even as their hosts died out and were replaced by new animals for the bugs to feed on.